Cool. Check. Yeah, it looks okay.
Cool. Find stationary points via calculus and determine their nature. So 18C, 18D. Cool. So first thing, start with something that we already know. Should we be able to draw that?
Yes.
Yep, go.
Oh,
Nice.
walking with that one.
Why did the learning?
Yeah.
Why didn't you do that?
We got 1 minute.
Oh boy.
1 minute, quick. Second. Tyler's done. Riley's done. Justin's done. Yep. TJ's done. Aaron's done. Gary's done. No, you're looking. You are done. Cool. Do we need any longer, or are we good? Tyler's good. All right. Let's find out. Cool. Aaron, you're up. What do you get? Just want the end result. Just want the end result. What does it look like?
So you have, so one of the y-intercept is 0,
Yep.
12.
Yep.
The x-intercepts are negative 6, 0, negative 2, 0.
Go.
The counting point is negative 1, negative 4.
Yeah. Anyone want to posit anything different, or are we all happy with that? Everyone's happy? Yeah. I have no idea if that's right or not. No. But if everyone's happy, then we'll go with it. Cool, I've got this, fantastic. So we did a whole bunch of stuff. We figured out all the important points, great. I want to do something, oh sorry, no. I also want to do that one as well. So you got another minute. Ready, set, go.
Can I turn this off?
Yep. Yeah. What's it set to?
Not even why.
It's set.
I just literally flip the switch.
Yeah, some people don't understand, by setting the heater to a higher setting, it just keeps going after it reaches that temperature, it doesn't go any faster. So it's,
Yeah, I wrote the wrong station there.
It's equivalent to putting a bigger cup under one of those fountain soft drink dispensers and go, oh, if I put a big cup there, it'll fill up faster. No, there's only a certain amount that comes out.
Yeah, well.
Oh, we're all still going, okay.
I just thought it'd be.
Why?
Because I was thinking about ego.
you stuck or what's going on? Yep.
You know you complete the square.
Yeah.
How do you do that again? I have the middle, and what do I do with K?
You figure out K because you essentially expand the part that you've got at the start,
Yeah.
right, which will match the first two terms, and then you'll have plus something, but you want plus something else at the top.
I was gonna ask you, like, what do you?
It's because showed us like this whole different
Yeah,
method.
you can do it different ways.
And,
No, it's more than one way of doing
and then
things.
I was trying to learn your way, and then I forgot both of the ways instead.
Good job. So you've got that.
Yeah.
Right, complete square gets you to there. If I expand this out, I'll get the same thing except I'll have plus 4 on the end. So K needs to be 1, so that I have 1 onto it.
So you get plus 4 at the end, and you add 1 line.
Yeah, so K is 1.
Oh, that makes sense.
Wait, why?
If you expand this out, what do you get?
Get plus 4 at the end.
You get, okay, yeah, you get plus 4 again. You get x squared plus 4x and then plus 4. But what I want is plus 5.
Oh, so you plus 1. Oh, I get it.
There you go.
Yeah, that's really simple to understand, but I will forget that in 10 minutes.
Okay, that's why you actually do the homework and the practice, so that you can't forget because you don't do any practice. Anyway,
No, so if we got to talk a whole different method, we got to talk plus 4
2,
minus
3,
4,
4, 5,
minus
6, 7, 8, 9. Dean, you got this?
I don't think so.
You don't think so. Fletcher? No. Tyler? No. Oh, this is not good. This is basics. This is from year 10. Michael got it? No. TJ's got it? Yeah? Alright. What do you got, TJ?
So x equals 4 and negative 10.
4 and neg 10, okay.
Y equals 40.
Uh,
Turning point equals positive 3 and 49.
positive,
3 and 49. Negative 3 and 49.
negative 3 makes more sense.
Yeah.
Something like that. 3, negative 3. Cool. Is that what we got?
Oh, yes.
Yeah. Yes, no?
I've got the negative 10 and the 4, the
Other way around?
negative 4 and 10, which then leads to 3 and 49.
Definitely. Squared is 9, minus 49, so I get 349, yeah, it should be over that way.
Oh, yeah, that's what I said. I accidentally said negative 40.
Pretty sure you didn't, but okay.
Yeah, that's because I stuffed it up because I was
Yep. 4, this is now positive 3, which will come over here now. This is 4, this over here. Cool, okay. Beautiful, so we end up with that, hopefully. Okay. If we're not ending up with that, that looks like you guys need to go back and remember how to do quadratics. Conveniently, there's a whole lot of stuff on YouTube that I've uploaded now, so you can do that in your own time. Beautiful. So, that's that. That's all well and good. Alright, if I now ask you to sketch this, alright, is that going to be straightforward? No, why? What would you normally do?
Simplify.
Simplify? Okay, how are you going to simplify it?
Divided all by 2.
Doesn't that change what the graph is?
I mean, like factorize it.
Okay, factorize it is good.
So,
Okay, so I want to try and factorize it. You could try and divide by 2 and then try and find some stuff. I'll tell you now, this one is not nice. Alright? But we can still figure out what this thing more or less looks like. Okay? What we're going to do is, what kind of graph is that to begin with?
cubic.
Cubic specifically, so it is a polynomial, but specifically it's cubic. Cool, okay, and it's a positive cubic at that. What could it possibly look like?
Like a squiggly line.
A squiggly line, yeah, with how many squiggles?
1.
One squiggle? Okay, depends what we're talking about as a squiggle, I guess. So it could look like that,
One inflection.
or it could have the inflection version. Alright, so we've got two possible ways that this thing could look. Well, without doing a lot of work, it's not really obvious what that would be. We could throw numbers at it all day, but that's going to get really tedious, and because some of these numbers are quite big, that could very quickly run away, and we could make errors all over the place. So we're going to do something different. I'm going to take the derivative of this. What do I get?
2x plus a.
Beautiful. Cool. What does the derivative talk about? The gradient. Is there anywhere interesting on this curve that has an interesting gradient?
Turning point.
Turning point has a gradient of
0.
0, right? So specifically, right, right, the gradient should be 0. So that means this should be talking about this equation, right? When the derivative is 0, so when the derivative function is 0. Okay.
Oh.
A bit of fiddling around, x should be -4, and lo and behold, that's what spits out.
Ah.
Cool, so that's a nice, quick, easy way of finding turning points. Okay, well, let's do it for the next one. So, we end up with this. The derivative of that, what do I get?
-2x plus 6.
Cool, okay. I want that point where it goes to 0, so this is now going to go to 0, okay. Therefore, x is 3. Hey, look at that. Cool. Alright, great. If I knew where the turning points of this thing were, would that tell me what the shape more or less was?
Yes.
Yeah, right? Because one of them has no turning point per se, but the other one has 2 turning points. Alright, so let's try that. Cool, we derive this, what do we get?
6x squared
Squared.
minus 6x
6x
minus 36.
minus 36.
Cool.
I should have said the wrong number. See what happened?
Just catch me out. Cool, alright. I've got the derivative. What am I going to make the derivative equal?
0.
0, right? Because that will tell me where I have turning points if they exist. Great. Is this easy to solve?
It's easy.
Yeah.
Yeah, what's your first move to make
Divide
it
by
easier?
6.
Plus 36.
Right. Divide
Take
everything
out a
by
factor of 6. Oh yeah, you can divide it all. Yeah.
Cool. What do you get from there?
-3 positive 2.
There you go. Beautiful. So, at those x coordinates, we have some kind of turning point. Which one's the maximum, which one's the minimum?
What's the maximum?
Okay, so, when we went over here, alright, I had a minimum for that one, and I had a maximum for that one. How do I know which one's which?
Why is it?
Put the y-intercept in,
We sum it back into the original equation.
that's better. Right? If I sub these in to the original equation, that would give me where they were. Okay, fine, we can do that. So, f of 3 equals 2, 3 cubed minus 3 squared minus 36, 3 plus 24. Okay,
That's a lot.
3 cubed,
27. 27.
27, times 2,
54. 54.
51. 54.
3 squared,
9.
times 3.
-27. That's you, DJ.
Let me just pull up my calculator.
Is that 108?
108.
Let me get this one. 24.
You should get this one.
Yeah, TJ, you're all over it, man.
Okay, so man, so checking bro. So 54 minus 24 would equal 27.
27, yeah.
-50.
Ah, 54
Every
plus
negative 57? Is it negative 57?
I don't know.
Ah, 6.
Negative 57 sounds good.
Nice.
Yeah, TJ.
Cool, okay. Does that tell me if it's a maximum or a minimum?
Looks like, no, you need something in the other one, right?
Right, I need the other one. Why?
Because you can't compare what you don't have.
Perfect. Right, it's possible that this one is higher or lower than that. I don't know.
Exactly.
Okay. What was it?
Negative 2.
Cool. You calculate. You think. We'll see if we land on the same result. Hopefully we do. Yeah, I should hope so. Should be able to do this in like, yeah, 8, 9, I guess. 2, 3, 4, yes, no? No, yes, 4, still going, still going, still going. Oh, you got it? 5.
I don't know if mine's correct, I just took it.
So long as you're done. Slice is possibly done, but unconvinced. Title's done, I'm not done. Oh, just about.
Yeah,
Just about.
been done for a second.
Oh, okay,
Yeah.
just then. Other Tyler is. Yep, alright. Actually, better yet. On the count of 3, everyone just says whatever result they got.
Yeah.
You ready?
Yeah.
Like,
Wait, what are we
So I'll
answering?
go 1, 2, 3, bang.
Which one, no, what are we answering here though?
Whatever result you got.
Oh, no.
Oh, that's not the.
Oh, shit.
Ready?
No.
Why?
I just don't want to be ready right now.
Let's get my adding subjectives.
Cool, so I'm gonna go 1, 2, 3, number.
68.
I said I'm going to go 1, 2, 3, number.
Yes, DJ.
Don't worry.
Ready? 1, 2, 3,
68.
Did everyone get 68?
Yeah.
Actually?
Yeah.
Yeah.
So everyone's right or everyone's wrong?
I wasn't gonna say it until TJ said it earlier. So I feel like
Yeah, that sounds reasonable. Okay. Beautiful. Okay, so which one's the maximum, which one's the minimum?
Don't know. It's a bit hard to tell.
Negative.
Negative 2
Which
is...
one is which? And you're telling me that,
So the first one that we did is the minimum,
right?
and the other one would obviously have to be minimum as well, a maximum as well. Just note it down.
Cool. So we've got some curve. Okay. We know that one of the points is at negative 2, 68, which I'm just going to put up there. And we know that the minimum is 3, negative 57, which is down here. Sorry, positive 3, negative 57. Cool. Okay. What kind of graph were we drawing in the first place?
A cubic.
The cubic, so how's it going to connect?
With a line.
Thanks.
That is something fixed.
Ooh, too much curve. Something like that. Go.
Yes.
Something like that.
Nice.
Wait. So we're actually supposed to find out all the exits?
Okay, so one thing at a time. Can we get this?
Yeah.
What is it?
24.
Beautiful. Read it straight off from the start. Now, you are welcome to attempt to find these. They are terrible numbers. I set it up so that you could find the turning points easily, but most of the time, if you can find one set easily, the other set's a pain. The most nice numbers that you can start with anyway, without putting a whole lot of fractions in everywhere. Cool, beautiful. Alright. I want you now. Oh, sorry, no.
Are we not going to?
Yeah, so how do we...
How
We just stop,
do we
that's
find
it.
the x-intercepts here?
That's just it?
I'm not going to make you do it because for this particular set of numbers, they're terrible.
How would you do it?
Yeah, but if... Yeah.
The same way you've always done it.
So I'll take it none of them are integers.
Yeah, no.
Ah, okay.
So it just ends up being terrible.
And I'll also take it that we won't run into any of these in a test.
No, I won't give you terrible numbers in any stat where you don't have a CAS to support it.
It'd be pretty funny though.
I'll always jerry-rig the numbers such that they are workable.
Yeah.
Alright, cool. So I've got this now. Do we know what it looks like roughly?
Yeah.
A cubic again, right? Okay, so does that mean there's only one possible thing it could look like?
No.
No. We've got how many options?
Okay.
2, right?
Maybe the other one's already did that one.
Almost certainly. Okay, so what am I going to do to figure out exactly what this looks like?
You would find the turning points by doing that. You would derive
Okay.
function.
Find turning points, so derive. What do I get?
3x squared. Oh, no, you're all over it, did you? Oh, yeah.
Minus 1224 x plus 48 plus 0.
Plus 0, or just don't put it. Yep, cool.
Nice.
What am I going to do from there?
Make it equal 0.
Make it equal 0.
Divide by 3. I'll factorize it by 3.
Okay, yeah, so first thing, I want it to equal 0. Cool. Alright.
Divided by 0.
Why am I making it equal 0?
Because it's
If you're trying to
turning point.
Right, the gradient of turning points is 0, okay? So I've got, I can take out a 3 as theta third.
And just divide it.
That's a terrible is that 16? Cool, okay, so what are you going to do from here? Oh, actually, better yet, you guys solve. Just blind my build all the way.
Obviously, there will be 4 negative 4, negative 4, negative.
Oh, that's good.
And you just.
Oh,
There's only one, which will mean it's a.
It's got an inflection. It's quite an inflection. Yeah, that's exactly what it's quite an inflection here. Negative 4, negative 4, there's 4, 4.
Find the y coordinate as well. Once you've got the x, find the y. Right, I want to know what this whole thing looks like. Keep going. You don't need the x intercept though.
That's the one you said. The coordinate. Yeah. It is true. I just substituted positive 4.
Just double the
That's right, that just seems to. Oh, wait, no.
Everyone's got the x coordinate as a turning point, yeah?
That's right.
Go.
which gives you, gives you 30, Oh, yeah. 64 plus
192.
192, 196. 192.
What's 34 plus 36?
Also
No,
192.
196 is 14 squared, and that's where I was moving.
Yep.
It's a fast way of doing things.
It's 9, it's 100.
But I didn't make the adjustment. What's this, 192?
Absolutely.
Again?
Yep.
Oh, of course, because this is 4 and 4.
Yeah.
I didn't even need to do any work. So just cost me.
Threatening. Let's do a bit. I didn't even have to. You're flying at me. I'm like, all right.
Okay. Did something different happen?
Yes.
What?
We were given just 1 point.
Right, we've got one turning point. Does that make any sense?
What'd you say?
I mean,
Do we? How many turning points do we have?
It's an inflection.
Okay,
Quite
right.
reflection.
So, is it possible to have one turning point for a cubic?
Yes.
Well,
I mean,
no,
no.
1 point of inflection.
1 point of inflection is possible. Is it possible to have one turning point?
No.
No. So, this.
Becomes an direction.
It's actually dumb. We don't know if it's really correct.
But we only got one solution for it, so it must be an inflection. Great. Where are we going? 400. Hold that there. Yes. So 400. Great. What does the curve look like?
It's like it gets, it's like it gets steeper and then it goes to a gradient of 0 and then comes back up.
Yeah, which way is up in your case when you were drawing that?
So like,
you're adding in extra curves. Something like that. Yeah, you were having an extra curve at the here and here when you were drawing it, and then one time you draw it the other way around. A little bit confusing. Beautiful. And again, it's potentially possible to calculate that cubic, but I'm not going to make you do that at all. Because I don't actually care for this. Beautiful. Okay. So, based on that, if f prime of x equals 0, what could we say? Well, actually, let's say f prime of a.
That means
That would
that's-
equal
that's,
turning point or
that's-
inflection.
I don't know, friction
It
or...
could be a turning point or an inflection. Therefore, when x equals a, the graph has one of, what are my options?
Turning point or point of inflection.
Okay, let's be even more specific. How many options are there for a turning point?
2,
2. So how many options in total are there for the gradient equaling 0?
3.
3, right? What are they?
The turning point, the friction.
Minimum would be
Oh,
fast.
yeah.
maximum and...
Which colour do they use? So we have a minimum, a maximum. Oh, it's terrible.
Inflection.
Or
Just inflection.
inflection. Now technically that's a stationary inflection. There are other kinds of inflections.
Ah, yes.
But
Yeah.
they're not in methods generally. The non-stationary inflections, or at least you're not expected to deal with them.
Can
So
you
they
have
can turn up.
multiple inflections?
If you have a higher power, yeah. So if you have an x to the power of 6, you could have multiple inflections.
Would that be called minimum inflection and maximum inflection?
No.
It would just be called inflection.
So you're getting to a good point though. If I had say x to the 10 or something, I could have multiple wiggles everywhere. So let's just say, I had something that went like that. It's supposed to be straight. Let's say I had something like that. Well, which one's the maximum?
The highest one?
Okay, so that's a reasonable answer, right? Because maximum should be the highest thing. But then based on that, this thing keeps going forever. So shouldn't that be the maximum?
But it doesn't turn, does it?
But it's the maximum value. So we need a new tweak to our wording. All of these guys, that one, they're all local maxima. So multiple maximums, maxima. All these guys,
Local minimum?
minima, yep. Local min, oops. Oh, jeez, come on. Well, if we go up that way to infinity, right, that's the global
Maximum.
maximum, because there's only one.
And if it went downwards, it'll be the global minimum.
Right. There you go.
Are we going to be doing this year?
Yeah, that's why we're doing it now.
No, the global maximum is done.
You already have in some case. So if you take a look at this guy, I have a local minimum at x is -4. What's the global minimum?
12.
What's the lowest that graph ever goes?
Oh, the local minimum.
Oh, sorry, I think so.
-4 as well. So the local minimum and the global minimum is the same thing here. So you just call it the global minimum. Alright, same story for this. The local maximum and the global maximum are the same point. So that's fine. It's only when you have things like this that there's a distinction between local and global. Okay. Beautiful. Is there a local maximum or minimum for that last graph?
No.
Because it doesn't turn over at any point, right? You've got globals at the infinities, right? But there's no locals, right? So the takeaway is that generally, when you're looking for turning points and everything, you make your derivative equal 0, solve. You have to keep in mind that that gives 3 potential solutions though. Minimums, maximums, and inflections. Okay. So, finding the derivative equaling 0 is 18C. 18D is determining what the nature of it is. So the nature is which of those 3. Coolly. That's it. So 18C, 18D. Lovely. No questions, queries, comments? Yes? I'll turn this off first and then I'll deal with that because that's specific to the last time.